Next is 27. This one, interesting. So, let's say there is a building. A rock was thrown, is projected from the edge top of this building. Okay? And the initial velocity is 12.2. And at an angle of 53 degrees, that's the velocity. So the rock will go like this and hit the ground.
Right. These are projectile motion problems.
Yes.
He said when you do it, you always start VXO and VYO. VXO would be VXO cosine of the angle, and VYO would be VYO sine of the angle.
Sine of that angle. Yes, you're right. So you need to separate the beginning, right? VXO is 12.2 cosine.
Cosine of the
This
angle.
angle. So and if you calculate 7.3 with YO is sine, right?
Right.
So if you calculate 9.78, so that's the initial velocity, and then you can calculate what the question gave to you is when you hit the ground, the horizontal distance up here to the base of the building is 25 meters. Here is 25 meters. We know the velocity along x, right? 7.3. And when you hit here, it's 25 meters. So distance is velocity time. Okay, the distance is 25 meters along x is 7.3 times t. So you got the time, right? And then we consider along the y-axis. Along the y-axis, we want to know the distance here. Distance here will be velocity y0 times t plus t squared. The initial one, 9.78. And the time we can get from here is around 3 something. Okay. And then the acceleration will be negative 9.8. And then time 3 squared. So if you calculate here, you got 23.6 meters, which is D. It's just you separate into two axes and calculate the distance.
Because we didn't know the time, so that's why we had to do it along.
From this information, we can get the time along the axis. And then with the time, we can calculate
Okay.
how high is the building.
28.
Oh, that's relative movement, right? So here is a river. You can draw a coordinate. It's north, south, east, and west. So the river has a speed 1 meter per second to the east, right? It takes 20 seconds for a boat to cross a river. The boat crossed the river and went to here. Exactly north. What it's asking, what's the speed of the boat relative to the water? So the distance is 140 meters, and it takes 20 seconds. So that's 7 meters per second, which is the speed along y.
It's the velocity. Where's the speed? But
The velocity. Sorry.
so velocity is the change in the distance over the change of time. So it would be the distance over time.
Yeah,
Okay, keep going.
that's along the y.
Okay.
Right?
Mm-hmm.
But there is a speed of there is a velocity of the river. So you need to have a velocity along the axis, kind of cancel out the water
Mm-hmm.
velocity, right?
Mm-hmm.
So in the end, the question is asking what the speed of the boat relative to the water. So it should be the addition of these two velocity.
Right. So you have to get the velocity of the water
Velocity of the water.
with the velocity of going. The velocity of x and the velocity of y.
Yes. We got the y. And the x is the magnitude is the same as the water, but it's different direction.
So it would be the square root, right? This is the square root of
So
v.
Vx, Vy, which is 16 plus 49. 65.
How did you get the velocity of the x? It would be the same.
Velocity of the x
Yeah, how you got 16?
is 4. So
Oh, they
square
gave
is
you.
16.
They gave you what the
Yeah,
velocity was.
We know the water. The river flows with a uniform speed of 4 meters per second.
Oh, okay, so we had to find the speed of the boat,
Yes.
and then we took the magnitude of them both.
Yes.
Okay, keep going.
And then the last one. The river was kind of similar. The river was 200 meters, and it's also with a speed of 4 meters per second. The boat, it took the boat 20 seconds to cross the river, which it means along the y-axis. It's 10 meters per second. So and along the x, you need to have a velocity to cancel out the velocity of the water. So it's also 4, but in toward the west, right? And then that's the speed of the boat relative to the water. And it's asking you in what direction must the boat be pointed in order to accomplish this, it's asking the angle here.
Right, they run on the angle.
Yeah. So you know here is 4, here is 10, right? From here, 10, 4.
Okay. So
So
you just take
10
inverse.
theta. Calculate, you got the angle 22.
4, they gave us that?
Yeah, the water, the river,
And
has a uniform flow speed of 4 meters per second.
and how did we get the other 4?
The other,
It was 4. Oh, no, the other
boat?
angle was 10.
10, the river is 0.2 kilometer, and it takes about 20 seconds to get there. Right?
Mm-hmm.
Which means the velocity along the y-axis is 10 meters per second. Sorry, the distance divided by the time.
Would give you the velocity
Yes,
along the y.
along, we are talking about along the y-axis. Actually, it also moved in the, along the x, but it's 4, and here is 10. So sometimes the question will ask you
So where that 4 on top come from?
the same thing. No? Here is a square.
Oh, it just got me confused because I thought you put 4 on the bottom and 4 on the top.
I mean, you can remove this, but
Right, I get what you're saying. Right.
Yeah.
Okay. And then you just take the tan inverse of y
Yeah.
over
Yeah,
x.
yeah, you're right.
It would be 10 over 4, the tan inverse of 10 over 4. Because x would be 4 and y would be 10. And it's a tan inverse of y over x.
You mean here?
Yeah.
No. They asking you this, not this angle.
But won't the angle be the inverse tan of y over x?
It depends on where is the theta. For example, in this case, here will be y over x. Right?
Where is y? 10, right?
I mean, if the theta is here,
No, I'm speaking on the first one. Y is 10
y is 10,
and x is 4.
x is 4.
Okay.
In this case, you need to look at where is the angle.
Okay.
If it's asking you this one, that's y, that's y. The same thing.
Okay.
Y is y over x. If it's here, that's x over y.
Okay.
It depends on where is the angle.